So I showed you in the earlier video how to add mixed numbers and improper fractions. Now what I'd like you to do is be able to subtract them as well. When we were adding, we could just add up our integers and then add up our fractions and combine them. But when subtracting, you really can't do that, because this fraction may be smaller than that fraction, and you would end up with a negative number if you took this away from that, which would therefore need some of the 13 to essentially be borrowed to cancel out the negative. So rather than work with all that confusion, it's just much easier to turn both of these into improper fractions and then take them away. And that's what I'm going to do. Essentially here, what 13 is telling me is that I've got 13 lots of 4 quarters, because 4 quarters is the same as a whole one. So I've got 13 times 4, which is the same as 40. So 10 times 4 plus 3 times 4, which is 12, over 4. So I've got 52 over 4. So I'm going to rewrite that as 52 over 4, and then I've got to include my extra quarter. So I've got 53 over 4. So I'm going to rewrite down here that 3 quarters equals 53 over 4. I'm going to use this again later. Then I'm going to work out what 8 and 5/6 is as an improper fraction. So 8 is essentially, in this case, 8 lots of 6 over 6, because it's 8 whole ones. 8 lots of 6 is going to be 48. So I have 48 sixths. So that's 8 is the same as my 48 sixths. They're exactly the same number, just one written as an integer, one written as a fraction. And then I have to include my 5/6 as well, which gives me 53 in total. So I know now that 8 and 5/6 is the same as 53 over 6. Now what I can do is take them away from each other. So I'm going to rewrite both of them in the correct order. Always be careful of that. That's why I rewrite them, so I don't lose track. Minus 53 over 6. So I need to make sure now that they're both in the same size pieces, because at the moment quarters are much larger pieces than sixths. So I need to rewrite both of them so they're in identical base pieces. So I need to check which times table they will both fit into. So 4, 8, 12, 16, 20, 24, 6, 12, 18, 24. Now notice, and this is why I've specifically picked these numbers, that we end up with 2 numbers that they can both fit into. Some of you were probably told by teachers just to multiply these 2 numbers together and work with them. But when you've got large numbers on top, it makes your life really hard. And that's why writing down, listing your times tables of your denominators allows you to pick the smallest number you can possibly work with. And this is called the lowest common multiple, because it's the lowest number that both of them will go into. So 12 is the lowest multiple of 4 and 6. So I'm going to rewrite my 53 over 4 into twelfths, and I'm also going to write my other 53 over 6 as twelfths as well. So to get from 4 to 12, I'm going to times by 3. So I'm going to have to times this number by 3 as well. So 3 times 50 is 150, plus 3 times 3, which is 9. So I know that my final answer is going to be 150 over 9. Then this one, I'm going to have to double. I'm going to have twice as many cuts to go from 6 to 12ths. So I'm going to have to double my numerator. So 2 lots of 53 is 106. So now I know that I have to rewrite these as 150 over 12. Sorry, that should have been 159 over 12. That's a silly error, sorry. So 150 plus 9 is 159 over 12. So 159, let's start again. 159 over 12 minus 106 over 12. Now, as I've told you in the previous video about adding and subtracting, that once you have the same denominator, you can write them as one sum. So we can write it as 159 minus 106 over 12. Please do not do 12 minus 12. It doesn't make sense. It just gives you 0. So now what I need to do is take 106 away from 59. So 9 minus 6 is 3, 5 minus 0 is 5, and 1 minus 1 is 0. So we end up with 53 left. So I know that I have 53 twelfths. So I can go back to my original sum and write down that I have, was it 53, wasn't it? 53 twelfths.